Hi, I'm John Scott. We're Team Minions.
And I'm Garrett Kintzele.
I'm Brianna Sauerland.
I'm Keegan, Lambe. This is the dimensional analysis of question 2b for pressure specifically. We start with the equation pressure is equal to rho GH, where rho is the dimensional of mass over volume, which then is mass over length cubed. Height is length. Gravity is the length over time period squared. So substituting these in, you have mass over length cubed times length over time squared times by length, which then simplifies down to pressure is equal to mass over length times time squared.
This is question 3b. We're asked to find the volume of in a core sample. To do that, we're going to be using the original oil in place equation, OOIP, using the given diameter, which is 6 inches, porosity of 15%, height of 3 feet, and water saturation of 25%. We plug this into the equation right here of area times height times 1 minus your water saturation times the porosity. We plug these in right here, and then we add in a conversion factor of 1 acre over 43,560 feet squared and multiplying it that by 7,758 barrels per acre foot. This gets our answer to barrels, which is 0.0118 barrels.
For question 4b, we were asked to define the bulk density with an equation. We know from the slides and lecture that eventually we're going to end with rho B, so the bulk density is equal to 1 minus porosity times the matrix density plus porosity times the fluid density. But how do we get there? We start out with the equations for density, which is mass over volume, and porosity, which is pore volume over bulk volume. From there, we can manipulate them and eventually get them into the equation that we want to see. So here's the work. We know that the mass is equal to the volume times the density. And if we were to expand this, we're going to have different densities for the rock and for the fluid. So if we were to expand this, you'd end up with the bulk mass is equal to the volume of the pore times the density of what's inside the pore plus the volume of the rock times the density of that rock. Now we're just going to step aside for a minute and rearrange our porosity equation to fit it into the rest of it. Here we have the porosity is equal to the pore volume over the bulk volume. We're going to rearrange it and get pore volume is equal to the bulk volume times porosity. Using that, we can plug that in for the pore volume right here. So you have bulk mass is equal to bulk volume times porosity times the density of the fluid plus bulk volume times 1 minus the porosity times the density of the rock. From there, you can divide both sides by the bulk volume. The bulk volumes will cancel, and it leaves you with the final equation that we wanted to get from the beginning. That's how you do problem 4b.
This is question 4c. We're defining porosity. Your porosity is equal to your density of your bulk density minus your matrix density divided by your fluid density subtracted from your matrix density. To get to that final equation, we did these stages of work. So your original equation that we were given in class is that your fluid density, or your bulk density is equal to 1 minus your porosity times by your matrix density plus your density, your fluid density times by your porosity. Fluid density, or bulk density, is then equal to this following equation, where it's fluid, your matrix density minus your porosity times by your matrix density plus your porosity times by your fluid density. We then factor it out and do some simple addition and subtraction, and then do a final division to get from this stage to this stage, where porosity is equal to bulk density subtract from your density of your matrix divided by fluid density subtract from matrix density.
For question 6, we were asked to make cross plots of porosity against resistivity and temperature against resistivity. The graph you can see is porosity against resistivity. In analyzing this graph, we can see that as the porosity goes up, in general, the resistivity will go down. Though you see a lot of points along the 0 line and you're like, what's up? That's totally not following the trend. But we can attribute those points to following dominated by other trends, such as a very low resistivity fluid in the pore space. Here you can see the temperature against resistivity graph. In general, you can see that the trend is increasing resistivity as the temperature rises. Just like with the porosity graph, you see many points along the 0 resistivity lines. This can be attributed to dominant other trends, such as the low resistivity fluids or conductive clays.
Hi, this is question number 9, and the first part of the question was, what is an oil-based mud and what is a water-based mud? An oil-based mud is something that is made using diesel or some type of synthetic, whereas a water-based mud is made using water.
Water-based mud and oil-based mud have different uses. Oil-based mud is going to be used when you have a lot of mud or clay and salt in your formation. It is used then because clay will swell when it comes in contact with water. Salt will also dissolve when it comes in contact with water, which causes an issue in your drilling fluid and the formation issues. You're going to use water-based mud when you need heavier mud and depending upon what your pressure requirements are.